Have you ever paused and wondered what would happen if one morning, without warning, the universe simply stopped following the rules we trust with our lives? Because that is exactly what happened today, as of March 3rd, 2026. 6 hours ago, something occurred that forced scientists to abandon calm language and switch to emergency protocols. NASA's Center for Near-Earth Object Studies has issued a Level 5 alert for an object known as 3I, Atlas, and this is not a routine advisory. This is the highest category of concern, reserved for events that should not happen under known physics. We are not discussing a small trajectory change or a mysterious signal buried in noise. We are talking about an event whose probability of occurring naturally is effectively zero. For 6 months, 3I, Atlas had been tracked as a single massive body, a comet-like object following a predictable path through the inner solar system. Everything about it fit the models. Its mass, its speed, its spin, all aligned with expectations. But at exactly 8 UTC this morning, the Deep Space Network facility in Goldstone, California, detected a sudden and violent spike in radar cross-section. What followed unfolded in just 14 seconds. 14 seconds that shattered every assumption about how dead rock and ice behave in space. The object did not slowly fracture or crumble under thermal stress as comets often do. Instead, 3I, Atlas, separated cleanly into exactly 50 distinct objects. Fragmentation itself is not unusual. Comets break apart all the time. But what happened next defies the most basic principles of entropy. When natural objects break, their fragments drift apart chaotically, spreading outward like debris after an explosion. Disorder increases, energy disperses. That is how the universe works. But the radar data showed the opposite. These 50 objects initially ejected at high velocity, then abruptly stopped, not slowed. Stopped. And then they stabilized relative to one another, locking into a rigid geometric formation. Picture this carefully. 50 objects, each roughly the size of a city block, hovering in deep space, 240 million kilometers from Earth, maintaining precise spacing and synchronized motion. Nature does not perform formation flying. Rocks do not self-organize. There is no known natural mechanism that allows inert debris to arrange itself into a grid. When researchers at the Harvard-Smithsonian Center for Astrophysics reviewed the early models, the reaction was not excitement or disbelief. It was silence. Because when trajectory simulations were run for these 50 objects, the results were deeply unsettling. Every model showed the same outcome. The swarm was no longer moving past Earth. It had altered its inclination and velocity. The fragments were now on an intercept course with Earth's upper atmosphere. Worse still, they were not converging on a single impact zone. The telemetry indicated deliberate dispersion, with objects fanning out toward different latitudes and longitudes across the planet. This was not a random breakup. This looked like deployment. To understand why observatories across the world entered emergency lockdown within hours, we need to go back to the precise moment the separation occurred. At 14:15 UTC on March 2nd, NASA's Deep Space Network antenna DSS 43 was tracking the Doppler shift of 3I, Atlas. For months, the signal showed a single rotating body. Then, within seconds, the return signal fractured. One echo became 50, each high intensity, each stable. Skepticism was immediate. Instrument failure was the first assumption. But that explanation collapsed quickly. European Space Agency's Gaia spacecraft independently confirmed the sudden astrometric shift. The ALMA array in Chile detected matching thermal signatures. 3 independent systems, using entirely different measurement techniques, all recorded the same event. This was real, and the deeper scientists looked, the more the physics unraveled. The radar cross-sections of the fragments were nearly identical. Each object measured approximately 300 meters in diameter with a variance of less than 5%. Natural fragmentation does not produce uniformity. It produces randomness. Equal-sized pieces imply precision, not chance. And then came the formation data. 2 hours after separation, the objects stopped drifting entirely and arranged themselves into a perfect pentagonal grid, each fragment spaced exactly 4,000 kilometers apart. That kind of organization requires energy, thrust, and feedback. It requires awareness of relative position and constant adjustment. Ice and stone cannot do that, and this was only the beginning. Because shortly after the formation stabilized, the entire grid altered its velocity by 3.4 kilometers per second without any visible exhaust, jets, or sails. In orbital mechanics, that kind of delta V demands propulsion. Yet no propulsion was observed. By the time these calculations were confirmed, one conclusion became unavoidable. Whatever 3I Atlas was, it was never just a comet. And in the next phase of this story, we will see how its composition, motion, and behavior force scientists to abandon astronomy altogether and confront something far more alarming. The realization that this was not random debris forced scientists to reframe the entire event in real time, because once the swarm completed its formation, something even more troubling appeared in the data. At 1730 UTC, orbital analysts noticed a coordinated velocity shift across all 50 objects. This was not gradual orbital drift or gravitational nudging. It was a synchronized maneuver. Every fragment altered speed and direction simultaneously, behaving as if controlled by a single command system. In astrophysics, this kind of movement has a name, non-gravitational acceleration, and it should not exist in inert celestial bodies. To put this into perspective, imagine throwing 50 stones into space and watching them suddenly change direction together without any visible force acting on them. Gravity cannot do this. Solar radiation pressure cannot do this at this scale. There were no outgassing jets, no plumes of vapor, no signs of propulsion that comet science relies on to explain anomalous motion. Yet the numbers were undeniable. The swarm executed a delta V of 3.4 kilometers per second, instantly rewriting its future trajectory. When those updated orbital paths were projected forward using the parameters released by the Minor Planet Center, the results were chillingly precise. Instead of a single impact corridor, the projected paths formed a wide cone intersecting Earth's rotation. This meant timing mattered. These objects were not simply heading toward Earth, they were accounting for the planet's spin. Each fragment was adjusting to arrive over a different region of the globe. That alone pushed the probability of a natural explanation beyond breaking point. Then came the composition data. Spectroscopy readings from ground-based observatories and orbital platforms began filtering in, and they contradicted every expectation. Comets are made of water, ice, carbon dioxide, silicates, and dust. They have messy, uneven chemical signatures. What these 50 objects reflected was entirely different. The absorption lines did not match ice or rock. They matched refined metals. Strong titanium signatures appeared repeatedly, along with unfamiliar alloys that exhibited selective radar absorption. That detail explained why tracking had become difficult almost immediately after separation. These objects were not just solid, they were engineered to be stealthy. Titanium does not naturally accumulate in these forms in space. It requires smelting, purification, and controlled manufacturing. That single fact shifted the conversation from astrophysics to engineering. We were no longer observing a strange natural object. We were observing hardware. At 1945 UTC, the situation escalated again. Data from the Keck Observatory in Hawaii and the Very Large Telescope in Chile shows the swarm accelerating sideways relative to its orbit, not inward toward the Sunday, not outward into deep space, sideways. Tangential acceleration of 0.08 meters per second squared was recorded across multiple fragments. That may sound insignificant, but over millions of kilometers, it allows precise targeting. It allows aim. When analysts extended those vectors 6 weeks into the future, accounting for lunar gravity, atmospheric drag, and Earth's rotation, the impact pattern became unmistakable. The fragments were spacing themselves to maximize surface coverage. North America, Eurasia, South America, Africa, Australia. The swarm was distributing itself globally. The odds of that happening by accident are effectively zero. This was intentional placement. Yet even with all of this, many scientists hesitated to call them weapons. Something about the behavior did not fit a simple impact scenario. That suspicion deepened when another signal emerged. The same radio pulse detected months earlier, once dismissed as noise, returned, but this time it did not come from a single source. All 50 objects transmitted simultaneously. The signal was brief, less than 4 milliseconds, hopping from one object to the next in a cascading sequence. It was peer-to-peer communication, clock synchronization, telemetry sharing, coordination. The swarm was not 50 independent bodies. It was a network. At this point, denying intent became impossible. Synchronized separation, artificial materials, controlled acceleration, and inter-object communication are not products of nature. The only remaining question was purpose. Why deploy now? Why reveal themselves only after entering a position from which Earth could not ignore them? The answer began to emerge as analysts compared timing windows. The swarm's acceleration curve aligned perfectly with a rare orbital configuration, one that allowed maximum access to Earth's satellite infrastructure. And that realization set the stage for the most disturbing discovery yet, because the next thing these objects turned their attention toward was not the planet itself, but the machines we rely on to understand and control our world. That shift in focus became unmistakable when the lead object, now labeled Probe Alpha for internal tracking, altered its orientation in a way no natural body ever would. Instead of continuing along its optimized descent vector, it rotated deliberately, aligning its primary sensor array toward Earth's geostationary orbit. In other words, it wasn't looking at the planet. It was looking at our satellites. That single action reframed the entire situation. This was no longer about impact risk alone. This was about access. Within minutes, observatories detected a surge in electromagnetic activity centered around the swarm. These were not random emissions or background radiation spikes. The signals were narrowband, tightly focused, and pulsed with machine-like precision. Engineers initially assumed the objects were passively scanning, mapping, radio noise, or sampling solar interference. That assumption collapsed when the data was decoded. At 1:14 UTC, the Green Bank Telescope in West Virginia intercepted a transmission that did not resemble anything previously observed from space. It was not a mathematical greeting. It was not a prime number sequence. It was not noise. It was structured data, and worse, it was familiar. The signal matched known encryption, handshake patterns used by Earth's own satellite networks. Specifically, it aligned with legacy authentication protocols embedded within the GPS constellation. To understand how serious this is, you need context. Modern military-grade encryption relies on rotating keys, layered authentication, and time-based synchronization. Cracking, even a single node, requires immense computational power and time. Probe Alpha did not crack it slowly, it did not brute force it, it mirrored it. The signal demonstrated full protocol comprehension. in milliseconds. That means it didn't guess the encryption. It already knew it. At that moment, the conversation inside space agencies stopped being theoretical. If these objects could communicate with each other, adjust their trajectories, and interface with human-made satellites, then they were not just observing us. They were interacting with our infrastructure. Within 2 hours of confirmation, an unprecedented decision was made. The entire GPS Block 3 constellation was temporarily taken offline under the guise of a maintenance reboot. This had never happened in the system's operational history. Financial markets, aviation systems, and power grid managers were quietly switched to backup timing protocols. Governments did not make announcements. They didn't need to. The silence itself was the message. But Probe Alpha wasn't finished. Embedded within the transmission was a final data packet, smaller than the rest, easy to overlook. It wasn't encrypted. It didn't need to be. It contained a simple set of coordinates, latitude and longitude, not in space, on Earth. When analysts plotted those coordinates, the room reportedly went quiet. The target was not a capital city, not a military installation, not a population center. It was Antarctica. Specifically, the Ice Cube Neutrino Observatory at the South Pole. That choice matters more than almost anything else observed so far. Ice Cube is not a weapon. It is not a communication hub. It is a detector designed to observe high-energy neutrinos passing through Earth from deep space. In other words, it watches the universe for events humanity cannot see with conventional telescopes. Targeting it is not random. It is either curiosity or strategy. If this were a peaceful probe seeking understanding, bypassing governments, and going directly to scientific instruments, would make a strange kind of sense. But if this were a hostile or precautionary act, then neutralizing a sensor capable of detecting cosmic-scale events would be tactically brilliant. You blind the watchers before you act. As this realization spread, another data stream began to spike. IceCube itself started reporting neutrino flux levels far above baseline. Something energetic was happening, not just near Earth, but somewhere along the swarm's approach path. Whether the probes were emitting particles, triggering interactions, or simply passing through an already active region of space was unclear. What was clear was timing. Everything was accelerating. The swarm continued to adjust its formation, tightening spacing, refining angles, behaving less like falling debris, and more like a coordinated fleet preparing for atmospheric entry. And with every hour that passed, one conclusion became harder to escape. Whatever 3I Atlas once was, it is no longer dormant. It has transitioned from transit to operation, and the next phase will unfold not in distant space, but in Earth's immediate neighborhood. By the time analysts finished correlating the neutrino spike with the swarm's trajectory, a deeper pattern started to emerge, one that shifted the narrative yet again. This was no longer just about objects approaching Earth or systems being accessed. It was about sequencing. Everything the swarm was doing followed a clear order: separation, formation, acceleration, communication, targeting, and now sensing. Each phase, built logically on the last, like steps in a procedure rather than reactions to random conditions. Inside emergency coordination rooms at NASA, ESA, and partner agencies across Asia, scientists began running simulations not of impacts, but of intent. The question quietly changed from "what will they hit" to "what are they trying to learn?" because the behavior was no longer consistent with weapons. If destruction were the goal, there were easier ways. A single kinetic impactor at interplanetary speed would be enough. Instead, the swarm was spreading out, measuring, synchronizing, and now actively interfacing with Earth-based detection systems. As IceCube continued to register elevated neutrino counts, researchers noticed something even stranger. The spike wasn't chaotic, it was directional. The incoming particles showed anisotropy, meaning they were arriving preferentially from the direction of the swarm's inbound path. That ruled out random cosmic background events. Something associated with the objects was either emitting high-energy particles or interacting with space in a way that generated them. Either possibility was unprecedented. At the same time, Probe Alpha adjusted again. Rather than maintaining a fixed lock on Earth's satellite belt, it began cycling through narrow pointing windows, briefly aligning with different orbital planes. Low Earth orbit, medium Earth orbit, polar orbits. Each alignment lasted only seconds, but the pattern was deliberate. It was sampling, mapping traffic density, signal behavior, timing drift. This wasn't curiosity in the human sense. It was system analysis. Meanwhile, the other 49 objects mirrored the behavior with slight offsets, creating overlapping coverage zones. If viewed from above the solar system plane, the swarm resembled a moving sensor mesh sweeping across Earth's technological footprint. Every emission, every reflection, every transmission bounce was being cataloged, and crucially, this was all happening without any detectable waste energy. No exhaust plumes, no thermal spikes, no signatures of inefficient propulsion. Whatever powered them operated cleanly, quietly, and far beyond known human engineering. This is where older assumptions finally collapsed. For decades, theoretical discussions about extraterrestrial probes leaned heavily on radio beacons or overt contact attempts. What we were seeing instead was something subtler and far more sophisticated. This was reconnaissance without announcement, observation without intrusion, at least not yet. A classified briefing leaked just enough detail to confirm what many scientists already suspected. The swarm's internal communications were not constant, they were event-driven. Bursts occurred only after new data thresholds were reached. In other words, the objects weren't chatting continuously, they were updating a shared model. That implies onboard processing, memory, and decision-making frameworks capable of revising priorities in real time. Even more unsettling was the energy budget analysis. As the swarm drew closer to the Sun, its available power increased, but not in proportion to simple solar absorption. The conversion efficiency suggested advanced energy harvesting, possibly leveraging fields or particles rather than photons alone. This meant that as time went on, the swarm wasn't weakening. It was becoming more capable. Publicly, officials maintained calm language. There was no announcement of threat, no evacuation plans, no acknowledgement of non-human technology. Privately, contingency planning expanded beyond anything seen before, not because an attack was imminent, but because uncertainty was absolute. Humanity had no precedent for this kind of encounter, not hostile, not friendly, just observant. And that may be the most disturbing possibility of all. If the swarm's purpose is assessment, then Earth is being evaluated, our technology, our responses, our signals, our ability to notice and adapt. The probes have not fired a weapon, they have not sent a greeting, they have simply watched, measured, and learned. As the countdown to atmospheric entry continued, one truth became unavoidable. Whatever happens next will not begin with an explosion or a message. It will begin with understanding who, or what, is doing the observing, and whether we are merely subjects in an experiment whose results we do not control. As global monitoring intensified, analysts began to realize that the most revealing clues were not coming from what the swarm was doing, but from what it was deliberately not doing. There were no attempts to interfere with communications beyond passive access. No satellites were disabled, no data streams were corrupted. Even the GPS handshake, alarming as it was, left systems intact once the vulnerability was demonstrated. It was as if the swarm wanted to prove capability without causing damage, to show that access was possible without exercising control. That restraint mattered because it suggested a purpose that was observational rather than aggressive. Attention shifted to timing. The objects were now close enough that light delay was no longer a major factor. Commands sent from Earth-based radars and telescopes were returning reflections almost instantly. This allowed researchers to build real-time models of the swarm's behavior. Those models revealed another pattern. Every maneuver, every signal exchange, every adjustment happened at moments when Earth's own systems were most active, during peak satellite traffic, during periods of high network load, during times when power grids, navigation systems, and scientific instruments were operating at full capacity. The swarm wasn't just studying Earth, it was studying Earth under stress. At the same time, a subtle shift occurred in the neutrino data. The flux detected by IceCube began to oscillate, rising and falling in a rhythm that matched the swarm's internal communication bursts. This correlation was small, but statistically significant. It implied coupling between whatever process powered the objects and the high-energy particles reaching Earth. That raised an uncomfortable possibility. The swarm might not only be observing our detectors, it might be using them as part of a feedback loop, gauging how its own activity registered within our measurement systems. Then came the atmospheric projections. Updated models showed that the objects would not enter as a single wave. They would arrive in staggered phases, separated by hours. Each phase corresponded to a different altitude band, from the upper thermosphere down toward the mesosphere. This ruled out impact scenarios almost entirely. The entry angles were too shallow, the velocities too controlled. Instead, the profiles matched insertion trajectories, the kind used to place instruments into orbit or to deploy high-altitude platforms. As this realization spread, the language in internal reports changed again. The word intercept quietly disappeared, replaced by interaction. The swarm was not crashing into Earth. It was integrating itself into Earth's environment, layer by layer, system by system, and it was doing so with an understanding of orbital dynamics and atmospheric physics that exceeded anything humanity had ever demonstrated. Another detail emerged from polarization studies. Reflected sunlight from the objects showed adaptive surface properties. Their exterior was not static. It altered reflectivity depending on wavelength and angle of incidence. In effect, the probes were tuning their visibility, making themselves easier or harder to detect, depending on who was looking and how. Optical telescopes saw one profile, radar systems saw another. Infrared sensors saw yet another. This wasn't camouflage in a military sense. It was optimization, a way to manage observation without fully hiding. Behind closed doors, ethicists were brought into discussions normally reserved for engineers. If this was first contact, it was not following the scripts humanity had imagined for decades. There was no greeting, no warning, no demand. Just presence, capability, and patience. That forced a hard question. Was humanity prepared to respond at all? Because any response, even silence, would be data. Any broadcast, any defensive move, any public announcement would reveal priorities, fears, and coordination limits. The swarm, meanwhile, continued its steady approach. No sudden accelerations, no dramatic displays, just precise, consistent motion. It behaved like a system executing a long, planned sequence, one that did not depend on surprise. That suggested confidence. Whatever intelligence lay behind these objects did not appear to be in a hurry. By the end of the day, one conclusion had taken root among those closest to the data. This event was not about invasion or salvation. It was about assessment. Earth had crossed some threshold, technological, environmental, or observational, that made it worth examining up close. The swarm was the instrument of that examination, and with less than a month before the first objects brushed the edge of our atmosphere, the most unsettling realization settled in. The moment of discovery was already behind us. The moment of decision was approaching. What mattered now was not what the swarm intended to do, but how humanity would choose to behave once it understood that it was no longer alone in watching the sky. As the countdown shortened, a strange calm settled over the global scientific community. Not relief, not confidence, but focus. The data streams were no longer surprising. They were consistent. Every hour reinforced the same conclusion. The swarm was behaving like a diagnostic tool, not a weapon. It adjusted trajectories with care. It modulated emissions with restraint. It avoided damaging interference, even when it clearly had the ability to do so. That restraint became the most important signal of all.